And boom. You can see that. Yeah. So finish 8-4, 8-3 kind of already been done. Let's see, 8-5, gonna start on. The 8-3, 8-4 quiz prep will post on Pearson today. You have 5 chances with the quiz prep, so you learn how to handle a quiz on Pearson. It's different than homework. I'll walk you through some questions. On the 27th, on Thursday, that's when the 8.3, 8.4 Pearson quiz is going to post at 1:15. It's due by your voting on Friday, 11:59 that night. So basically by the next day, by 11:59. There's 2 attempts. I'll keep the best of the 2 scores. I'll also post a review sheet and summary for Chapter 8. Next Tuesday, we review, and we'll take the test on Thursday. So working with a quiz on Pearson is different than homework. Want to make sure we do this. It's being recorded. Victor, make sure the little red light's on. Can I see it? Yep. It's like they're right down there at the bottom. Yeah. Okay. So the quiz stuff is out right there. 8.34, practice, and then right here, attempts, 0 out of 5. That's so I haven't done it. We'll open that up. So you already see that it's different. Are you ready to start? 7 questions. The quiz itself only has 4. But there's multiple parts. You'll see in the practice. Okay. I want to show you what this means. Walk through it. If you need to see an extra tutorial in their language, you can always watch that. But you can always refer to this video in case you get stuck. Let me just start. So here we go. 1 out of 5 points, or 1 out of 5 attempts. There's 42 points. Right there, it says 7 questions and saving progress. And as you can see, you can only work on 1 question at a time. You cannot work ahead. You have to go in sequence. The problems will be scrambled. So when you do the second attempt, they'll be in a different order. Okay? Get started. Here's question number 1. Find the prime factorization of the composite number. So you're supposed to write this as a prime factorization. So this is something that we'll make sure we go over. Basically doing this today. Little factor tree. So we have 130. Give me 2 numbers that factor and multiply. Give us 130. What type of what? Hello? It ends in a 0. Actively participate in your own education. 2 numbers that multiply. Give me 130. 10 times 13. So 10 times 13. 2 numbers will make 10. 5 times 2. And what about 13? So 13. But whenever you do a factor tree, read all the branches down at the bottom. These are all prime numbers. So 130 times prime factorization is 2 times 5 times 13. Doesn't matter if you work it. Why don't, if somebody said put these letters in alphabetical order, wow, isn't that great? They have that song to help us remember. Numbers that actually can be put in order because that's the whole purpose of an order. Why wouldn't you make me try to figure out my order? Because I'll put them in order. It's not going to kill us. Yes, put them in order. Or you know what? What if you don't, but Pearson is not going to tell you when you punch it in on a quiz. It is not going to tell you if you got it right or wrong until you turn your quiz in and tell you what you got. So watch. If I take the chance and don't put it in order versus just putting it in order. Maybe they'll take it, maybe they won't. I don't play games. I don't roll the dice. You still put it in 1, 2 times 5 times 13. You still do it. On a chip. And then instead of right here, instead of check answer, like you have on homework, it's next. Okay. So it's not going to grade it as you take it. So go to the next problem. This one has 3 parts. Oh, leap years. Leap years occur in years that are divisible by 4. However, if the years end in 2 zeros, it must be divisible by 400 in order to be a leap year. Oh man, I forgot. Oh, it must be divisible by 400. So 2000 was a leap year because 400 goes into it. You know what? This is what's so amazing about astronomy. Somehow they figured out that the orbit of our Earth is not just 300. Wouldn't it be nice if we just said 360 days, make a nice round number? It's 365 days. Why don't we just make it 360? Because if we did, all of our seasons would be off. We might be having snow in July. Well, what about 365 and then 0.25? It's an orbit 365 in a quarter day. That's why we add a day every 4 years to balance out the calendar. But every 400 years, that's when you get an extra day. That counts as a leap year. But like 2100, 2 zeros, no leap. We take it back. And that's just from observing the stars that we rotate, the stars, and as we rotate around our own sun, and as our seasons change, and as our Earth spins. A little bit of that. Determine whether the years 1325, 277, and 1100 are leap. Well, first of all, every 4 years. So it has to be divisible by a 4. If it's not divisible by 4, it's not going to be a leap year. So what do you think? Is 1325 a leap year? Does 4 go into it? No. Part 2. 2077. Is that a leap year? Well, we actually already did that on the quiz on Thursday. We didn't count 2077. That's a. And do you see how this one was yes and then no? But here it's no on top and then yes. You got to pay attention to what you put. That's a. And then 1100 is 1100 divisible by 400. 400? 400. So it says it must be divisible by 400 to be a leap. No. 400 goes into that. It would have to be 1200. The year 1200 would be a leap. 400 is not. So these are all notes. Next. And then time factorization of 297. So the last one we had ended in a 0. That was kind of nice. 297 doesn't. So I can't divide by 2. Let's check through. 2 plus 9 is 11. 11 plus 7 is 18. 18, it's divisible by 3 because 3 goes into both. And well, 18 is also divisible by 9. I can divide by 9 when use a bigger factor. So I'm going to use 9. Can I use 6? No, because it's not even. If 6 would work, it would have to be divisible by 2, and 2 is not good. So 297 divided by 9. Can't go into 2, so we go to the test place. 9 goes to 29 3 times, and I get 27. So 7 minus 0 is 7. 9 minus 7 is 2. So that's 9 to 27 another 3 times. And sure enough, it goes in even. So this is 9 times 33. So that's 3 times 3 times 3 times 11. So the prime factorization, this is how you write it. 297 is equal to, how many 3's are there? 3. And right here, they use ascending order. So smallest to biggest. So right there with the red. So the smallest is 3. How many do we have? So 3 to the third times an 11. So you're going to want to write it using powers for the ones that repeat. Okay? Here's how you get the exponent. So we type in 3, and then this thing. That is our toolkit, our toolbar. You click there, and here's our common templates. So multiplication, fraction, mixed numbers, and then this one, the superscript. So this superscript is going to give us an exponent above that 3. So 3 to the third. Now you need to step down from the exponent. So if you just keep typing, if you just go times 11 right here, it's all going to be in the numerator, the exponents. Right? If I just keep going times 11, it's all up there. So pay attention to what you're doing. So you can use the mouse, or you can just use the arrows, and that'll pop you back down. And then times 11. And then you hit next. And then here we go. Let's say that it's time to feed the dogs. That's what would happen in my house. Bubbles has come up to me and she's looking at it. She knows when 5 o'clock when it's 5. She doesn't know her name when we're calling her name outside. She knows the time. So here's the deal. I have already clicked to go to the next one. I'm on question 4. So I'm going to hit resume later. I'm going to come back to you later. And here's the problem. If I try to step away and resume later, or I'm sleepy, it's time to go to bed or whatever. If I leave this page, I will automatically submit this and all previous questions. I will not be able to change those answers. You will, however, be able to return to complete questions that have not yet been visited. Once you hit resume later, you can only do problems that you haven't seen yet. I've already opened up question 4. I won't be able to come back. I've done it, but I won't be able to come back and do it. So what you need to do is, if you open it, do that problem. Instead of hitting next, then you resume later. If you accidentally hit submit quit, and by the way, I hit resume later, it doesn't kick me out. It says, are you sure? It's one of those cancel. If I accidentally hit submit quit, because in homework, we're used to hitting save. So I'm going to go ahead, like I'm thinking, I'm going to save it. By accidentally hit submit quit. Are you sure? I haven't finished the quiz yet. You have unanswered questions. Are you sure you want to submit this assignment? If you submit now, you won't be able to change your answer. It'll grade what you've done. So, well, no, I want to submit it. I'm not done. But I want to finish this problem. Prime factorization for 392. So let's see, 392. That's 12. 3 times 12. 12 plus 2 is 14. So 3 doesn't work, but it is even. But since it's even, I'm going to divide it by 2. 2 times 100. Oh, sorry. Yeah. 186. Two goes in 39, 196. So 2 times 196, and then that's still even, so that's a 2, that's a 2, and that's 2 times of going to be 98. All right? So I got a 2, and I got a 2, and that's 2 times 49. So I got a 2, and I got a 2, and I got a 2, and I got 7 times 7. I just whittling it down. Okay? If I had used and checked the divisibility rule for 7, so I'm looking at 2, I double the 2 and I get 4, and I go minus 4, I get 35, the 7 was 35. Yep, I could have divided by 7 instead of 2. But whittling it down by 2 is fine. How many 2s do we end up with? So that's 2 to the 3rd times how many 7? 7 to the 7. Two, and then I need the exponent. It's not u, super then the 3rd, and then times 7, and I need the exponent to the 2nd. Now, be careful. I got to go feed the dogs. Bubbles is a little bit mad. So now I hit resume later. We're still going to ask me. And when I come back, I've finished question number 4. So when I see the screen about resume, I wish I could get rid of this one. As you can see down here, question 1 is locked because I've already done it. Question 2 is locked. Question 3 is locked. Question 4. I can only open up question 5 because that was the next question that I haven't done yet. And then I have 5, 6, and 7 left to do. Now, we'll show you what happens and how you get what's new. How you know if you want to do the problem. How if you want to do the second attempt or not. So let's say I finished the quiz. I'm not going to do the other problem, but I'm finishing the quiz. Submit. It's going to tell you what you got. Okay. So I submitted my quiz. My score right here. I got a 57.14%. 24 out of 42 points. And it's going to show me what review right here. And it says, because these were all nice and green check marks, I got number 1 correct, 2 correct. All the problems I did, I got correct. And then I didn't do those because those were ones that but the ones that I did, I got them. If I got something wrong, I could go and click on that problem and show me what I got wrong. So, advice. If I attempt to complete that, you need to practice making sure you know how to put answer stuff in a quiz situation. The quiz questions are just like the 4 quiz questions you would see on the quiz itself. Don't wait until 11 o'clock or 11:30 to do your quiz on Friday night. Make sure you give yourself enough time. In fact, the quiz prep is not going to be available between, it's going to stop at 11. Because if you haven't practiced before 11 o'clock on Friday night, you should be just doing the quiz. We have 2 attempts to keep the best of the 2 attempts. All right. Still got to find prime numbers. We'd be looking for primes. What if we wanted to find and check and see is 899 so are we going to do a sieve of Aristophanes all the way up to 900 so we can check? I hope not. But this is called trial division. Trial division is a method for determining whether a number is prime. Trial division. That means guess and check. It works by checking if any prime numbers divide the number in question. Remember what the sieve of Aristophanes does. You cross off, you circle the first prime number, then you cross off all the multiples of that prime. Circle the next one, you cross off all the multiples. So you cross off the multiple of a prime number. If it's a multiple of the prime number, that's all you care about. So what we're going to do with trial division is you take this 899 and we're going to check the division, but we're only going to use prime numbers over here. Does 2 go into it? 3, 5, 7, 11, 13, 17, 19. So these are the numbers we're going to check. We don't need to check all the other numbers. I don't need to check a 6 because a 6 isn't prime. If 6 goes into it, who cares? Because 2 would have gone into it earlier. We know it's not even, so 2's enough. A little bit of disability can kind of be nice. 8 plus 9 is 17. 17 plus 9 is equal to 26. 26 is not divisible by 3, so 3 is enough. Doesn't end in a 5 or a 0, so 5 doesn't work. That's enough. Let's say you don't remember the divisibility of over 7. So we check 7 the old-fashioned way. 7 goes into 8 one time. In the 100. So we have a 9, a 9, and a 1. In the tens place, 7 goes into 19 2 times. We get a 14. And then we subtract, and we get a 9, and we get a 5. 7 goes into 59. 59 8 times, and we get a 56, and we have a remainder. 7 does not go into it. We get a 128 with a remainder of 3 sevens. That's a no. You also get to use your calculator if you want. We check 11. So 11 goes into 89, not in the hundreds, but in the tens place, it would go in 8 times, and that would be an 88. And when we subtract, we get a 9 and a 1. Oh, no, well, so that goes in 81 times with a remainder. Well, it's still check. You see, I do want to write this out. I do want to write this out because when do I stop? So 81 times 11, and that gives us an 8, so 8 11ths. So feeds on into that is going 6 times, that's going to 6 times. So 7 times 2. 6 times is 78, and we get 9, and we get 1, and we get 1. And then this is going to go in. Oh, nine times is going to give us 9 times is going to give us 117. So we get a remainder of 2. Seventeen back, 3 from 17 from 51, 4 times 17 from 32 here. So it is 78. 6. Pardon. 4 times 17 is 68. 5 times 17 is equal to 75. 6 times 17 is 42 or 60. So that's not. So this is 5. So 5 times 17 is 85. And we get a 9, we get a 4. 17 into 49 is going to go in 2 times. And that gives us 34. 34 will subtract, we get 5 and 15. So 52 remainder of 15 and 17. Check 19. 19 goes into 899. 19 goes into that. So 4 times is too big. 3 times is going to give us 30 and 27. That's 57. 4 times is going to get big. So 3 times is going to give us a 57. We're going to give it 9. We're going to give it 2. We're going to give it 3. What should 76? That's going to see 4, 76. So we get a 9, we get a 3, and we get a 1. So that's better. So now we're going to go 139. So we go 139, and we're going to go in 10 times. So that would be 190. So we're going to go into 8 with no. 7 times 19 is going to be 63, 6, and we're going to go 1, 33. So that's going to be a 7, 133 with remainder 6. So 0.7 and 6 17ths. Next prime number is going to be 23. Okay, 3 times 23, so that's going to be 60 plus, that's supposed to be 69. 4 times 23, so that's 80 plus 3, plus 12, so 92. So it's going to be 3 times 20. 3 times 23 is going to give us 69. So we get 9, we get a 0, and we get a 2. So 209. 10 times 23 is 230. So 9 times 23 is going to give us the 7 equal 2, and we get 82, we get 207. We'll get a remainder 2. But we're getting close. Prime number from 3 to go to 24, no, from 5, no, from 6, no, from 7, no, what's the next one? 23. Two times 29 is going to give us 68, 58. 3 times, well, 3 times more. 27 and 60, so that's 87. Oh. 60 plus 27 is 87. So we subtract, we get a 9, we get a 2. There you go, look at that. And 29 is prime, 31 is prime, so those go back. Now let me show you magic with the calculator. By the way, I'm going to brag at some point, but one of my former students helped redesign Dodger Stadium. He's an architect. He was also my son's best man on 11. And 7 World Series to the 2025. So we want to know what goes into prime numbers going into 890. So in my equations, the way how I got there was with my calculation, I get y. So there's my equations. Those are the things I can type in for graphing or for a table. And I'm going to type in 899 and then divide by, and then I'm going to use the variable x. And I'm going to hit enter. So now whatever I plug in for x, the calculator is going to do the division for me. So table is right here above the graph button. I don't care what the graph looks like, I just want numbers. So right above the graph button in blue is the word table. To activate the blue function, you have to hit this second. It's in blue. So I'm going to hit that second key. And then I'm going to press the table button. And there's a table. And here are values of x. And here's the answer when you divide it into y equals 899 and divide by whatever's here in x value. So you don't have to type it in every single time. 899 divided by 899 divided by. So if you have numbers in there already, I'm here at the top of the column for x's, and I'm just going to hit this button that says delete. Hitting clear is not going to clear. When you hit delete, deletes the value. If you cannot clear the value, That's because you have to reset your table 7. So if I go to just in case, you have this. Let me show you. If you accidentally have that, where it looks like this, where you have the numbers already there. And if I try to delete, it's not going to let me delete. So what I do is, I can't delete them, it's because of the table setup. The table is automatically starting you with one value for X. Delta table says we're going to increase the amount of X 1 unit at a time. So it's going to start with 0 and then 1, 2, 3, 4, 5. And it's going to independently, the calculator is going to input values of X by itself. It's going to do numbers from 0 to 1, 2, 3, 4 and keep on going forever. But it's doing it on its own. That's why I can't delete it. What I want the calculator to do is I want it to do the independent variable. That's the X. Dependent is the Y. The independent variable, I want the calculator to ask me, which means I want to put in my own number. So I just need to scroll down, scroll on down to that independent, move over to the ask, and then I want to hit enter. So now it's blinking on the ask, and then I just go back to my table, and now I can put in my own numbers. And so we were checking the primes. Divide by 2, that's got a decimal. Divide by 3, that's got a decimal. Divide by 5, that's got a decimal. Divide by 7, got a decimal. Divide by the next one is 11, a decimal. Divide by 13, another decimal. Divide by 17, we got another decimal. Divide by 19, got another decimal. 19 went to 23, we got another decimal. From 23, they went to 29, no more decimal. There's our pattern. How long did it take to do that versus how long did it take to do it by hand? But you just have to know how to use the technology. You only get to use regular calculators, no tablets, no phones, no blah, blah, blah. On your test, when we actually do the test, I'm going to have you make sure you can show me how to find all the primes from, it's not going to be more than 100, I don't think. But you have to be able to show me a certain number of primes from blank to a blank by sieve of Eratosthenes. So show me you can use the sieve of Eratosthenes to do it. And I will print the that table. So you can just cross it off and show that you can do it. Okay? So this question there, from 0 to 6, from 1 to 65, I don't want you to have to worry about writing it out. Okay? So we're not going to do this right now, but we've done enough of it. So sieve of Eratosthenes finds all the primes from blank to blank. Trial division. The question was, is it prime? Which is one number, is that number prime? So we're not doing the sieve of Eratosthenes, we're getting all the other primes. Just want to know, is that one number prime? So different kind of question. Katie. That was Katie's afterwards. Katie was asked to factor 26 times 77 into a product of prime numbers. So if she was asked to factor factor 26 times 77. Of course, you're going to do this to me. And we want a product of prime numbers. So the first thing Katie did was she multiplied these two numbers together, and she got 2002, and then she made a factor tree. If I go projector back up. So then proceeded to make a factor tree for 2002. Is Katie's method most efficient? In other words, is this the best way to find the prime factorization for 26 times 77? So multiply them together and then make a factor tree for 2022. So maybe she goes, all right, that's even. So I'm going to go 2 times 1001. I mean, why not? What do you think? Why? What times what is going to give us 26 times 27? 77. What are the prime factorization? Should I multiply them together and then take it apart? I'm looking for factors. Should I put this IKEA bookcase together before so I can figure out how it works, and then take it apart so I know how it works? Should I put it together first and then take it apart to see what makes it work? So if I'm trying to factor something, why multiply first? I'm supposed to take a look. I have two factors. Basically, I want the prime factorization for this. If anything, why not start with 26 times 77? Maybe those are bigger. And if I'm going to start with 26 times 77, why in the world did I multiply them together in the first? Make sense? So if I want the prime factorization for this product, then I'm just going to go ahead. I would have a 2 and a 13. I would have a 7 and an 11. The connection that comes with this problem is because it's written as a word problem. If I asked you to find the prime factorization for 26 times 77, I doubt most of you would actually multiply that together and then try to break it apart. Because we're just looking for the factors. So why not just start factoring? But when it's asked in a word problem fashion, is this the most efficient? And you're now trying to synthesize, what are you asking of? Why are you asking me this question? Can't I just do the factorization? Stop it. I don't have an opinion. I don't want to judge Katie. Katie's my friend. But seriously, that's how you approach word problems in mathematics. With our own, sometimes, insecurity, we might have some trepidation about how or if we want to answer a question like that. You're going to be in front of a classroom with students, and sometimes you have to be so emphatic about how you say something, whether it's true or not, and you have to make them believe that you believe it. if you can convince them that grass is blue, you're a great teacher. Because you have been able to get a point across in some way, shape, or form. Now, granted, it's like hypnotism. You want to take them out of that trance. Or you can start with let's pretend. So before use the sieve of Aristophanes, which the Pauli shows all the time number from 1 to 100. Now, technically, I gave you a list of them. There's a list in your notes. Okay. Is that prime or composite the number 20? So you're clicking on it. The 17 prime composite or neither? Well, let's look at that one. Is the answer going to be a neither, a prime composite or neither when you're looking at 17? Is that possible for neither? So the fundamental theory of arithmetic says it's either prime or it's composite. And then click on all the ones that are prime. Find the prime factorization. Back to that one using powers, ascending order, prime factorization there, exponent. And this is how your quiz is also going to be. We solve it. Here, make your own factor tree, fill in the blanks. Prime factorization. Okay. So that's 4. Keep that. The most frustrating words for a teacher and a student. Greatest common factor, least common multiple. The greatest common factor, that means what's the greatest and biggest? What's the biggest number that gives into another number even? The greatest common. So there's 2. What are the biggest numbers that divide into the same number even? Greatest common factor. And they go into least common multiple. The smallest number. Least. The least common multiple means what is the smallest number that these 2 numbers can go into even? What's the smallest number that 2 numbers can actually divide themselves into another number? They're multiples. So it would be bigger than the original. When you add fractions with unlike denominators, we first find the least common multiple of the denominator, otherwise known as the least common denominator. So we may add like parts. To simplify a fraction, it is best to use the greatest common factor of the numerator and denominator to reduce the fraction faster. In this section, we will revisit the method and use to find the least common multiple and modify it to find the greatest common factor. So, don't worry about it for now. Let me explain something that we that we do when we interview a potential instructor. When we have an instructor come in and interview for a job, we want them to do a lesson. And we also ask them to demonstrate how they would handle a question that we might ask, a student might ask them. A student comes into an office and they're struggling. And they're really struggling with this concept. They want to know why 1/2 plus 1/3, why 1/2 plus 1/3 isn't 2/5. How come it's not 2/5? Which would be great if it did, because there's no real rules yet to figure out. But the question is, why isn't it? And we usually will get potential hires or instructors that will just start taking us through, oh, you need a common denominator. So they start explaining how to do it. That wasn't what the student cared about. That wasn't the question they were being asked. The question was, why isn't it 2/5? Students handle money. 1/2 of a dollar is how much? 50 cents. So that kind of makes sense. 1/3 of a dollar. So if you cut a dollar into 3 equal pieces, you get about 30 cents, 33 cents. And students can usually handle that. About 33 cents. Turn around more. So if you have 50 cents and 33 cents, you have 83 cents. Over here, 2/5 of a dollar. Well, what's 1/2 of 5? 2.5 is 1/2. Is 1/2 of 5. This is smaller than 2.5. 2 out of 5 is smaller than 1/2. If you have 2/5 of a dollar, you technically have 40 cents. Okay, this is smaller than 1/2. This is about 40 cents. So if you look at this and you add more than 1/2, or you have 1/2 and you add more to it, you certainly aren't going to get less than that. It doesn't work that way. It's impossible. So how we get the right answer is we have to make them like fractions, the same type of fraction of the same type of thing. Common fraction. Hence these common denominators. So we have to go get these common denominators and change fractions into the kind of fraction we use. Got some old-fashioned definitions here and before. The greatest common factor, GCF, of 2 or more counting numbers. The greatest common factor of 2 or more counting numbers. That is a factor of all the given numbers. The least common multiple, LCM, 2 or more counting numbers, is the smallest counting number that is a multiple of all the given numbers. Greatest common factor. That's the biggest number that I into evenly I have two numbers like that. Let's go. 65 and 91. Well, the factors of this are 5 times 13. And the factors of this are 7 times 13. The greatest common factor that goes into both 65 and 91, 13 divide each one even. The biggest number that divides each one even. What do they have in common? And that's nice when you try to reduce fractions. If you have 65 over 91, you can only reduce common factors. So 65 is equal to 5 times 13 over 91 is 7 times 13. You can only reduce common factors. So when you reduce this fraction, you end up with 5 over 7. Factors goes into factors whenever they go into another. It's common multiple. Least common multiple of 2 or more counting numbers is the least and the smallest. Is the smallest counting number that is a multiple of the given numbers, or all of the given numbers, so there's more than one. So, some multiple is the smallest. Sometimes I like to say, what's the first number? Smallest number that is the first by into human. So they become multiple. Those numbers have to go into the multiple. They go into least common factor, what goes into them. So factors go into the number. Multiples, what do they go into? So they're multiples of the number that's bigger than the number. So when I ask for things like this, when I ask for what is 1/8, let's go 5/8. And we're going to minus, let's go 7/12. And we need the least common denominator or the least common multiple. And I'll ask this question. The least common multiple. So we're looking for what is the least common multiple. What is the first number that 8 and 12 divide into? What goes into, what do they go into even? And I will always give this answer 4. That's a factor of 8. That's a factor of 4. What do they go into? What's the least common denominator? They have to go into it because I have to change these fractions into the same kind of denominator. I can't change this into a 4. What is it? 24. The least common multiple, the first number that 8 and 12 both go into is 24. We're looking for multiples. So you could list them out. You got your 8 and you got your 12. So 1 times 8 is 8, and then you got your 16, and then you got 24, you got 32, and you keep on going. And then you got 1 times 12, and then 2 times 12 is 24. Oh, there's the first number that they both divide evenly. That's the least common multiple. So now I can rewrite these fractions with the least common multiple or least common denominator, 24. And to change this into 24, I would multiply by 3 over 3. This is now 15 over 24. And to change this fraction into a 24 denominator, I'd have to multiply 2 over 2. So the equivalent would be 14 over 24. So now I have the same type of fraction. I have 15 of these 24ths. I want to take away 14 of those 24ths. So 15 of the same kind of thing. 15 of them, take away 14 of them, and I'm left with 1 of those 24ths. Okay? We're going to speak that language. Multiples versus factors. What goes into them? What do they go into? We can find the greatest common factor by listing all the factors of each counting number given and find the largest one that they have in common. So list all the factors and circle the biggest one they have in common. Okay. You have the time, don't know what the number is. We can find the least common multiple by listing all the multiples and circling the first one that they have in common, like I did here. Here's the multiple of 8, here's the multiple of 12, there's the first one they have in common. Here's the multiples of 65, here's the multiples of 91, there's the biggest one they have in common. But is there another way? You betcha. It's a method called the slide. This is the slide method. You will have to be able to demonstrate it as the slide method. So you must learn how to reproduce this method. See what our practice do. We are going to use find the least common multiple and the greatest common factor for 8,810. Least common multiple and the greatest common factor 8,800 and 10,000. Okay. Well, we did it the old-fashioned. You would list all the factors of 8,800, all the factors of 10,000. The biggest factor is your greatest common factor. You list all the multiples of 8,800 and list all the multiples. List some multiple and some multiple. And the smallest one they have in common actually is common. Or make sure you practice. Draw a little line like this. You put your two numbers over here to the further right. Move the bar right here. I'm going to put 8,800. I'm going to put 10,000. And I'm going to put a little line right here for a third column. Pick a number that you know, just simple number that would go into 8,800 that would also divide 10,000 evenly. The biggest number you can think of would be great. Check your zeros. What's the most zeros they have in common? Look, 2. So what number ends with 2 zeros? 100. I can factor out. They're both multiples of 100. I'm going to factor out 100. So 8,800 divided by 100 is going to leave what's going to leave? And I divide this one. This 10,000 divided by 100 is going to leave what? A 100. So now you're looking at 88 and 100, and you do it again. What do you see as the greatest or the biggest number that goes into 88 and goes into 100 even? Two. Let's go 2. So if you use 2, so we would do 88. You know, I keep doing that. It's like a 88 divided by 2 leaves 44. And then 100, and we divide by 2, that leaves a 50. Do we have any other common factors that we can take out of a 44 and a 50? 44 is even. 50 is even. So we can take out another. They're both even. We can take out another 2. So we got to do it again. So we took out 100. We got 88 and 100. So we took, factored out 2. So we're going to factor out another 2 because that's even. 2. So we got 44 divided by 2. So that's not 22. And we factor up another 2. So 50 divided by 2, and that's 25. So you're looking at 22 and 25. Do they have any common factors? No. So we're done with that. We're done. What should I have taken out the 88, 100? Instead of going 2 twice. 4. That's okay. It still works out. So follow this. The least common multiple. How do you spell? What's the first letter of the word least? Now, trick question. What's the first letter of the word least? L. The least common multiple is going to be made with an L shape. So you're going to go like this. The least common multiple is the product of this column times that row. All of these multiplied together. The least common multiple is going to be 100 times 2 times 2 times 22 times 25. That's where you're going to get your least common multiple from. $240,000. All right. The L, the least common multiple is the L. Listen. The greatest common factor. Just on both. And it was just finding common factors going down that column. The greatest common factor is this. Just this column. So the greatest common factor is the product of 100 times 2 times 2. That's your greatest common factor. This is your GCF, just this column. And the least common multiple is this L shape. So 100 times 4. The biggest number that goes into both of those is 400. That's the slide method. So between now and Thursday, practice your quiz. And we'll pick up and finish 8.5 on Thursday.